So we're talking about set operations. There are 4 types of subsets. The first one is disjoint sets, which is when you have a set A and you have a set B. They're disjoint if they have nothing in common. So basically, the intersection, which looks like an upside down U, A intersect B is equal to the empty set. Because they have nothing in common, that makes them disjoint. Now subsets, we've talked about a subset before in the last section. So when A is a subset of B, every element in A is also an element of set B. If they're equal sets, then set A is equal to set B, and all elements of set A are elements of set B, and all elements of set B are all elements of set A. So you can see they're basically the same. Okay? Well, they're not basically, they are the same. They're the same set. They're equal. Overlapping sets are when sets A and B have elements in common. We're going to do a lot of intersections. So the intersection of sets A and B are symbolized by that A intersect B. It's a set containing all the elements that are common to both set A and set B. So intersection means and. So think about if you have 2 streets that intersect. This point here is their intersection. What do they have in common? Well, whatever's on the 4 corners of that street, they would have in common because they're kind of on both sides. So that's an intersection. Think about streets that intersect. Now the union of a set is symbolized by A union B. It looks like a U. They're not really U's, but they look like it. It's a set containing all the elements that are elements of set A or set B. So intersections, it has to be in both, so it's an and. Union is all of this set and all of this set, not where they just overlap, but both sets together, no matter if they have them in common or not. And then we have the complement. So the complement is everything like, so if we're looking at set A, it's an A apostrophe is the notation, and it's a set of all the elements in the universal set that are not in set A. So if this is set A, everything outside of set A is a complement. So here we have some diagrams that kind of show that again, where you can see this would be the intersection. The union would be both complete circles. So here's the intersection, this is the union, okay? So that's the union, that's an intersection. You can kind of see the shaded part there. And then we have something called set difference. That's the set of elements that are in B, but not A, denoted by B minus A. So we have, this would be this shaded area here, is it's in set B, but it's not in set A. So you have to take out the overlap part if you only want B and not A. And then we're going to talk about De Morgan's law here in a few minutes. If A and B are sets, then the complement of their union is equal to the complement of A intersected with the complement of B. And the intersection, if you take the complement of the intersection, it would be equal to the complement of A union with B complement. So let's go look at some examples. Sometimes I think it's easier to cover the verbiage and then let's go back and look. So for example 1, we want to find the union. So if I have set A is equal to the set 1, 3, 5, 6, and 8, and set B is equal to 2, 3, 6, 7, and 9. If we're looking at A union B, let's just change those to union and intersection. I think we can do this for both. If we're looking at A union B, that means I'm looking at the union. That means all of set A, all of set B. You don't have to put them in numerical order. You can if you want to. You could list just all of A and then go see what else is in it. So I'm going to do this two ways. It would be the same answer. So I can do 1, 3, 5, 6, and 8 because that's all of set A. Then I'm going to come over to set B and see if I already have that listed because they're not always numbers that you use. Well, I don't have set or number 2, so I have to add that, but I already have the 3. I already have the 6. I need the 7 and the 9. So you could do it that way, or you can go numerically. You could say, well, I've got 1 and 2 and 3. I don't have 4 in either one, but I have a 5, a 6, a 7, an 8, and a 9. So both of these would be a correct answer. You can do it either way, numerically, in order, or just do all of set A and then add in what you don't already have for set B. All right, let's look at the intersection for these two. So what do they have in common? Well, A has 1, but B doesn't. A has 3, and so does B, so I can do that one. A has 5, but B doesn't. A has 6, and so does B. And A has 8, and B doesn't. Now, I didn't look at the 2, the 7, and the 9, because if A doesn't have it, it doesn't matter if B does or not. If it's not here, it has to be in both. So just 3 and 6 would be our intersection. All right, so let's now take this and draw a Venn diagram. So if we want to draw a Venn diagram of this, we're going to draw our box with our universal set. And we're going to draw 2 circles. We know they overlap because they have an intersection here. And we have set A and set B. Now what goes in the center is what is overlapping, which is the intersection right here. So 3 and 6 go here. Go back and look at 1. We don't have that one. We already have the 3. We need the 5. We already have the 6. We need the 8. And then over here, we can see that we don't have the 2, but we have the 3. We have the 6. We don't have the 7, and we don't have the 9. So that would be a Venn diagram representing our set, our 2 sets with our union and intersection. You need to know the intersection before you can draw the Venn diagram because you need to know what they have in common. All right, let's look at example 2. So let's find the complement. So if we have the union or the universal set is equal to 1, 2, 3, all the way up to 10, and set A is equal to 1, 3, 5, 7, and 9. So if you recall from our vocabulary, the complement is everything outside of the set. So if we are looking for a complement, that means it's everything outside of set A. So here's our set A. We want everything that's in the universal, but not in A. So not in A. So if I'm looking at my numbers, A has 1, but it doesn't have 2. It has 3. It doesn't have 4. It has 5. It doesn't have 6. It has 7. It doesn't have 8. It has 9. And it doesn't have 10. And remember, those ellipses tell us that it's all 1 through 10 are there. So basically, these are the odd numbers through 10, and these are the even numbers. So that would be our A complement. All right, let's do the same thing. Let's do this for example 3. So U is the set of people living in the U.S., the United States, and I is the set of people who have photos on Instagram. So our universal set is all the people living in the United States. Our set I is the set of people who have photos on Instagram. All right, so we need to find I complement. So that'll be the set of people living in the United States who do not have photos on Instagram. So I complement is the set of people living in the United States who do not have photos on Instagram. Okay? So it's going to be all of those who aren't there, but you have to keep it in the set of your universal set. That's why we have to add that United States part, because our entire set is looking at people from the United States. All right, let's go to number 4. So we're going to find the difference of sets. So we'll do part A. We want to find the set of 3, 6, 9, and 12 minus x such that x is an odd integer. So if you remember from the handout, if we were subtracting, taking the difference, then we were looking at like B minus A. So if we were looking at set B, subtracting out A, we had to take out the overlap. So this is a set minus odd integers. That means we have to take out all the odd integers. So what would be left is going to be the even ones. So this would be 6 and 12, because 3 and 9 would be taking out the odd integers. So we'll have 6 and 12. And then let's go look at part B. If A is equal to 1, 3, 4, 5, and 6, and set B is equal to 2, 3, 4, 6, 7, and 8. I got an extra apostrophe there, or comma, sorry. So now we're looking at A minus B. So if we have A minus B, so A minus B, well, the 1 will stay because it doesn't have 1. And we don't care what B has that A doesn't in this. We're looking at set A minus B. B has a 3, so we can't put that. It has a 4. It doesn't have a 5. But it has a 6. So 1 and 5 would be A minus B. Now we could also look at taking B minus A. So now we're looking at set B. A doesn't have a 2, so that will stay. But A has a 3, A has a 4, A has a 6, but A doesn't have 7 or 8. So when you subtract, going one way will be a different answer than going back the other way, because it depends on what's in your set. All right. So let's go look at example 5. So we want to look at doing unions and some complements here. So we're going to look at the order of calculating unions and complements. So I'm just going to write our universal set to begin with. So we have 1 through 5. So 1, 2, 3, 4, and 5. And set A is equal to 1, 3, and 5. And set B is equal to 1, 2, and 3. So for part A, we want to find A union with B complement. So this is about, we have to figure out the order in which we want to do this. If we want to find A union B complement, first we have to find the union. We got to know what the union is in order to find the complement of it. So what I'm going to do is I'm going to take and find the union. So A union B, that's all of A union with all of B. So we'll have 1, 2, 3, and 5. 1, 2, 3, and 5. So now I can take that to find my A union B complement. So I have to look here, and I have to take the complement of it. So what's in the universal set that is not in this? Well, I have 1, 2, 3. I don't have a 4. So 4 is going to be your A union B complement. All right, let's look at part B. So here we want to find A complement union with B complement. So in order to do that, we first need to know what our A complement is. So the A complement, we're using the same set here. So we have 1, 3, and 5. So we're going to have 2 and 4 for our A complement. We need to find our B complement. So 1, 2, 3, that means our B complement would be 4 and 5 because it's whatever's not in B. So now we can find our A complement union with our B complement. So that means it's these two here put together. So the union between these, well, we have a 2, a 4, and a 5. Now what I want you to note here is up here we did A union B complement, and down here we did A complement union B complement. So it looks similar, but notice our answers are not the same. So this definitely tells us that the A union with B complement does not equal A complement union B complement. They do not equal each other. And it's good to have that understanding. All right, so let's go look at example 6. So for example 6, we are going to we're looking at De Morgan's law, which is, we're still looking at complements and stuff like that. All right, so if we have the union, or U, set U is equal to 1 through 10, all the way up to 10. And A is equal to 1, 2, 5, 7, 8, and 9. And B is equal to 2, 4, 5, 6, and 7. We are going to find the following. So we want to find, for part A, we're looking for A complement. So that means I have to find the complement of A. If we're looking at 1 through 10, it's going to be all the numbers that I don't already have. So this would be 3, 4, 6, and 10. Those are the numbers that are outside of our A that are in our universal set. So for part B, we're going to find the B complement. So when we're looking at B complement, it's everything outside of B. So we'll have 1, 3, we have 4, 5, 6, 7. So it'll be 8, 9, and 10. That'll be our B complement. For part C, we have A complement union with B complement. Well, we've already found the A complement, B complement, so now we just got to do a union of them. Remember, you can place them in order, or you can do them all of A and then put in B. It doesn't matter either way. So if we just put all of A, 3, 4, 6, and 10, or A complement, and add in the parts of B that we don't already have, we'd have 1. We have 3 already. We don't have 8 or 9. Or, remember, you could put them in order. So you would have 1, 3, 4, 6, 8, 9, and 10. All right, part D, we're looking at A union with B. So we're looking at set A and set B, and we're finding the union of those. So this would be A, 1, 2. We'll do it in order this time only. And then we'd have 4, 5, 6, 7, 8, and 9. So that would be A union with B. All right, part E, we would have A union B complement. So we're going to take the complement of this. So looking at our setup here, our universal set, we're taking the complement of this. Well, we know it's 1 through 10, so we're missing a 3 and we're missing 10. So this would be 3 and 10. All right, part F, we're looking at A intersect B. Well, that's where the two intersect. So what do they have in common? Well, they have a 2, and they have a 5, and they have a 7. That's what the A and B have in common. So now, let's go find part G. Let's do A complement intersect with B complement. So we found the union earlier, but now we're going to find the union of their complements. So that's what they have in common. Well, they both have a 3 and they both have a 10. So they have 3 and 10 for their complements. For part H, we want to find A intersect B complement. Well, we have the intersection here, so let's find the complement of that. So remember, it's everything outside of this, and everything outside of it is whatever's left over from the universal set. So we would have 1, 3, 4, 6, 8, 9, and 10. And then for part I want to find A complement intersected with B. Well, that's taking my A complement and intersecting it with set B. So what do they have in common? Well, I can see they both have a 4 and they both have a 6. Now, let's do one last part here, and let's construct a Venn diagram of our sets. So, all of those complements in that won't have anything to do with it. We will have our universal set, and we have set A, and we have set B, Now what they had in common, we go back to our intersections. So the intersection between A and B is 2, 5, and 7. And then in set A, we're looking for what was left in set A. So we'll have 1, 2, 5, 7, 8, and 9. And for set B, we have 2, we need a 4, 5, we need a 6, and we already have the 7. Now, we have to put out in the universal, we need to put everything that's not already in A and B. So I have 1, 2, I need a 3, 4, 5, 6, 7, 8, 9, I need a 10. So I have my 3 and my 10 in my universal set. So make sure you're understanding what all of these different notations are, or it's going to be difficult.